Welcome to Information Technology Video Developer Network. My name is Abdurrashid Hamid. I'm a certified Microsoft specialist working for Cyber Bionic Systematics. Today we are going to look at variables and data types. The first thing I want you to understand is the definition of a variable. A variable is a memory area that keeps a value that can be changed. What does this mean? By memory area, it means a location in your RAM, a location in your random access memory. And the value that you assign to it can be changed during your work. So, let's take a look at the example we have on the screen. Here we have created a byte-typed variable. We named it A and assigned a value of 2 to it. On the right-hand side, you can see the representation of 2 in the binary format. This B here means binary. So, look at this picture here. You have 00000010. This means 2 in the binary format. It's the same thing you have here. The location of your file or the determination of where your file or your value will be stored doesn't depend on you. So, you just create a variable, assign a value to it, and the computer knows where to put it. Okay? Let's take a look at the different parts of a variable. What do you need to create a variable? Creating a variable is easy. When you create a variable, you must specify 3 things. First, you must specify the type of the variable, the name of the variable, and the initial value. The initial value is how we assign a value to it. It is like how we initialize the variable. Remember that, yeah, about initialization of variables. So, here we have the same variable we created just a moment ago. Of course, the type of the variable is byte. So we have a byte-typed variable which can hold a value of 0 to 255. The name of the variable is A. In our case, we just named it A. You can call it whatever you want, but in this case, we have just named it A. And this is like the assignment sign. So we assign a value of 2 to A. This is how it goes. And the value of the variable is written after the assignment sign. Here we have 2 in this case. And of course your semicolon to show the computer that this string is closed. Initializing of a variable is the first assignment of a value to it. So if you don't assign a value to it, yes, you have created a variable, but you haven't initialized it. So please always try to initialize your variables. Here we have another example of a variable, in this case a short-typed variable. So we created a short-typed variable named A and assigned a value of 256 to it. Now, why are we using short? Remember I told you that a byte-typed variable can hold a maximum of 255. Well, if you need 256, what you need to do is to use the short type, because the short type has more capacity than the byte type. So here we have 2 bytes holding 256. This is the code for 256 and it's in the binary format. In the hex format, it looks like this. 0x, you remember the prefix 0x, and 100. This is just an example. It doesn't have to be stored in 0, 1, or it doesn't have to be stored somewhere. The computer decides where it's stored, not you. Let's take a minute and remember all the types of data keeping we have. RAM data types, ways of keeping data in a RAM. You remember this, I showed you in my previous class. This is the different types of ways we can keep data in a RAM. We can keep it in a byte, in 2 bytes, in 4 bytes, or in 8 bytes. For bytes, we have 8 bits. Remember byte, signed byte, and bool. Byte for numbers, S byte for signed numbers, negative or positive, and bool for true or false. For 2 bytes, we have 16 bits. It's also called a machine word. Again, we have short, U short, and char. In this case, short can have a value of a negative number or a positive number. But U short, which is unsigned short, just has a value, a number. Char, you remember, is for keeping characters. Yeah? A, you can keep B, you can keep C, and so on and so forth. 4 bytes or 32 bits, also called double machine word, is an integer typed. Int can hold negative, positive, and uint, unsigned integer, is just for numbers. Float, if you remember, we use for fractional numbers with a precision of about 7 digits after the decimal point. For 8 bytes or 62 bits, quadruple machine word, we have long, ulong, and double. Long for signed, meaning positive or negative, ulong for unsigned, meaning just a number, and double for fractional. Double has more precision than float. So let's look at this again. Data types. Predefined, object, string, dynamic. We know what a string is. Object and dynamic I'll show you in the future. Simple, numerical, and non-numeric. For the numeric, we have integer, real. Integer for whole numbers, which includes 8 bits, 16, 32, and 64, and S byte, so on. For real numbers, we have decimal, float, and double. Decimal has the highest precision, float has the lowest precision, and double is somewhere in the middle. For non-numeric, you remember bool and char. Bool for true and false scenarios, and char for character scenarios. We have been talking about variables for some time now. We've talked about variable types, names of variables, also known as the identifier. We've talked about the assignment sign and the value of a variable. Now, let's take a look at some rules guiding naming variables. Of course, there are some rules, and they are pretty easy to remember. The name of a variable should be clear and give an idea of the value kept. This means that if you want to name a variable, try to give it a name that will be easy for you to remember, and try to give it a name that you will associate with the value in it. For example, if I have my age, if my age is the identifier or the name of the variable, then maybe I should put my age, real age, maybe let's say 20 or 10 or 50, just to remember that 50 means my age. So here I'll show you some symbols that are accepted and some of them that are not accepted in the first letter and also in the rest of the body of the name. Let's start with the first letter. The first symbol of an identifier, we can use A to Z in capital letters, A to Z in small letters. We can use an underscore or the @ symbol. But for the first symbol of my variable or the name of my variable, we can't use 0 to 9, dot, commas, question marks, and all these. Nevertheless, when we move to the other symbols of an identifier, you can see we can use 0 to 9, which means it can have a number in the name of the variable. But still, you are not allowed to use these ones. Take note, can be used for the first symbol, but can't be used in between the name of the variable. So take a little moment or two and just take a look at this and remember them, please. Okay? Let's take a look at the next slide. These are some naming rules and examples that I've created. To use the symbols of alphabet and underscore in the identifier is allowed, meaning you can use A, B, C, D, and so on and so forth. You can use an underscore both at the beginning and in the middle of your name. So this is an acceptable approach. To use numbers at the first position is not allowed. So you can have, for example, my variable 1. 1 is a number. It's accepted. My 1 variable is also accepted. But 1, my variable, is not accepted. Why? Simply because you have a number at the beginning. So this is not a good approach. It's not accepted. To use reserved keywords as identifiers is prohibited. Keywords such as decimal, false, true, extern, they are not accepted. Okay? So don't use reserved keywords as identifiers, but you can use int my variable or int my var, just something like this. To use the at symbol is allowed only at the first position. You can use at my variable, but you can't say my at variable. This is not correct, but this is correct. So at the beginning or at the first position, it's accepted. C# language is case sensitive. So if you write them with different cases, you'll have two different variables. Just by changing the case, you have created another variable. So take a look at this. My variable, V in the uppercase. My variable, M and V in the uppercase. My variable, everything in lowercase. So these are three different variables to the computer, but they have the same alphabets, just in different cases. So just by changing one alphabet and put it in capital case, you will change the whole thing. Let's look at some keywords. Keywords are predefined reserved identifiers that have special meanings to the compiler. Things like abstract, base, as, bool, break, byte, case, well, you have a lot of them here. Of course, we have seen some of them, things like bool, we have seen byte, we have talked about char, decimal, and don't worry, throughout this course we'll take a look at almost all of them. Not almost, but basically all of them, just one step at a time. Keywords cannot be used to identify programs if they do not contain the at prefix. So to add at the beginning, the prefix, you can use a keyword to name your variable. The symbol at in the variable identifier shows the compiler that it is an identifier but not a C# keyword or its instruction. So if you only use char, the computer will look at it as a keyword. But if you use at char, then the computer will look at it as an identifier rather than a keyword. So keywords cannot be used as identifiers except if they have the at prefix at the beginning. So these are some of the keywords that we'll look at during our course. Next, we have contextual keywords. Contextual keywords can be used as identifiers. A contextual keyword is different. It is not a reserved keyword. So that's why they can be used to identify variables. As we go on, we'll also take a look at all of these. Let's move to the next slide. Case and convention. Specification of the C# language recommends to keep certain rules. Case and conventions when creating identifiers. So look at this. We have Pascal casing, camel casing, and uppercase. In Pascal casing, every word in the identifier starts with a capital letter. For example, my method, you can see my capital M, method capital M2. Remove, so capital R. Camel casing. Every word except the first one in the identifier starts with a capital letter. We have my count, so you see the first letter is in the lower case, but the second word starts with a capital C. Total discount. Total, first letter starting with a lowercase, but discount, the second word, D, starting with a capital case. Identifier consists of the letters written in the uppercase. So all the letters are in the uppercase. We have I-O, XML, everything is in the uppercase. To use Hungarian notation and start the identifiers with underscore is not recommended. Don't worry about Hungarian notation, I will explain as our course goes on. But for now, I just want you to keep in mind that Hungarian notation is another type of naming convention, in which the name or function of the variable indicates its type. So, On this, we'll close our variable topic and we'll move into constants. A constant is a memory area that keeps some value which cannot be changed. So, contrary to variables, you cannot change the value of a constant. It is there and that it is. Here we have constructed a variable. We created a constant byte typed variable named a and assigned a value of 2 to it. You do remember that this is 2 in the binary format. And the computer or compiler saves this value somewhere in one of these addresses. An attempt to assign a value to a constant, a new value to a constant, causes an error of compilation level. So it will not compile it, the compiler will not change the value of that constant because it's a constant, it's not a variable. That can only be done with variables but not constants. So let's move on to the next slide and see. Here we have casting or type conversion. Casting is just another word for conversion from one type to another. So if you have a variable of an integer type, you can convert it to another type. If you have a variable of a byte type, you can convert it into another type. That procedure is called casting. Casting is a conversion of a variable value from one type to another. Here we have two types of castings. We have implicit casting. It is like a safe type of casting. I will show you in the next slide. And we also have explicit casting. Let's start with implicit casting. Implicit casting or safe casting is a conversion of a value of smaller type to a value of a greater type, or conversion of a value of an integer type into a real type. What does this mean? This means that you are putting a smaller number into a bigger number. Just imagine that you have two cups. One of them is very big, the other is small. Of course, you can pour in the water from the smaller cup into a bigger cup, but doing it the other way will cause some spills. You'll have some spills. In programming, it's like you'll have a loss of precision. So here we have created a variable, a byte typed variable named a, and assigned a value of 10 to it. Of course, you remember that a byte is smaller than short. So short has 2 bytes, byte has only 1 byte. Of course, you can put this into this. So putting this 10 into a short, thereby putting this 1 byte into 2 bytes, what will happen is this. You will have 10, 10. We are putting this 10 into short. But then again, you see 0, 0, 0, 0, indicating that this is a positive number. If it is a negative number, you will have 1s here. So this is just a number. It's not negative. So you have 0, 0, 0, 0, and then you have 10 here. If it is negative, you will have 1, 1, 1, 1, 1, and 10 here. This is implicit casting, putting a smaller number into a bigger container if you wish. Now, let's look at explicit casting. Explicit casting, on the other hand, is considered unsafe because you risk loss of precision. Explicit type conversion or unsafe type conversion is a conversion of a value of a greater type to a value of a smaller type, or conversion of a value of a real type to an integer type. So converting a value of a real type, which of course has some fraction, cannot be put into an integer type because a real type has a decimal and a tail, where you have, for example, 7.332 or 7.213, whatever. You cannot put it into an integer type because an integer is a whole number and cannot hold fractions. So you risk losing those dots or digits after the decimal point. But in any case, look at this. We have created a short typed variable. We named it a and assigned a value of 256 to it. This 256 is purposely put here because I want to show you that a short can hold 256, but a byte cannot hold 256. Remember, the maximum capacity of a byte is 255, so it can only hold a value of 255. But on the other hand, short can hold a greater value. So here we have 256, and to put 256 into a container that can hold a maximum of 255 is possible, but you risk losing the precision. You risk losing some points or numbers or values or digits, whatever. The operator of an explicit type conversion. This is how an explicit type conversion looks like. Here you have, for example, b is equal to 0, or the value of b is 0, the value of a is 256. So putting 256 into this just one byte is possible, but with a risk of losing the precision. So you have this variable b is equal to, you open your bracket, you write byte to show the computer that you want to explicitly convert short into a byte, and then you write a here, variable a. So 256, you want to put it into a byte, and this is how you explicitly convert. Explicit casting is considered to be unsafe because loss of precision or cutting of number can occur. So this is basically explicit conversion in short. The last thing we're going to take a look at before we move into examples and exercises is formatted output. Formatted output is just a way of substituting elements into their respective positions or indexes. Look at this. We have console write line. This is number, and in this curly braces we have 0, comma, and then we have 1. You do remember that console is basically your keyboard and your screen. Keyboard for your input, screen for your output. And write line is just you're asking the console to write something out for you. Okay? This is number. You can see these curly braces are called the marker of substitution. And the 0 you have there is the element of substitution. So what you want is, you want the computer to take this one and put it right in here. So you are substituting this 0 for 1. Now, this is the easiest case. When you do something like this, what will happen is it will print out this is number 1. You will not see any curly braces and you will not see a 0. Here you have the result. This is number 1, and that's it. If you have two numbers, console write line, these are numbers 0 and 1. Remember that the computer always starts from 0. So what it will do is it will take the first number it has here, in this case 1, and it will put it where we have 0, the second number where we have 1. If we had a third number here, it will take it and put it where we have 2. But in this case, we just have 1 and 2. So 1 goes into 0, 2 goes into 1. The computer always starts from 0 and goes on. If you intend, or if you attempt to put a number greater than the index number, it will not work. So don't do that. Here we have console write line. Reverse 1 in curly braces, output 0 also in curly braces, and then you have comma 1 and 2. I told you the computer always starts with 0, so what it will do is it will take the first number we have here and put it where we have 0, take the second number and put it where we have 1. So what this should read is reverse 2, output 1. You have it here. Reverse to output 1. In the second example I gave you, you have these are numbers 1 and 2. These are numbers 1 and 2. In the third example, just because we reverse this 0 and 1, the computer also changes the places. So we have these are numbers 1 and 2. Here we have reverse to output 1. Take 1, put it into 0. Take 2, put it into 1. Another example I'll give you is console write line. Then we have 0, 2, 3, and then 1. What the computer will do is it will start with 0 always. We have 0, 1, 2, 3. So 0 goes into 0. We have 2, 2, 2. 1 goes into 1. So we have 3, 3, 3 at the end. 2 goes into 2. So we have 1, 1, 1. And 7, 7, 7 goes into 3. So we have 7, 7, 7. So 0, 1, 2, 3. 2, 2, 2, 2, 2, 2. 3, 3, 3. 3, 3, 3. Because we have 1 at the end. 1, 1, 1. 1, 1, 1. And 7, 7, 7. 7, 7, 7. You see? First it takes 0, 0, 2, 2, 3, 3, and then 1, 1. So this is formatted output. You can play with this, try it, and see how it works for you. But please don't remember to put your code in brackets first, then where you want to be substituted, you put them in double quotes. Don't forget to put your commas, and don't forget to put a semicolon at the end. So now I believe we're ready and we can start doing some exercises and look at some examples about everything we have learned today. What we're first going to look at is the constant. Here we have about 17 examples I'll show you. These examples are in our Solution Explorer. You remember that I told you you can have a lot of projects in your Solution Explorer. Well, this is a good example for you to see. So, let's get to the point. A constant is a memory area that keeps some value that cannot be changed. This means that if you assign a constant value, you cannot change it. In variables, you can change the value of a constant, but here you cannot. What does this mean? Here we have created a double type variable named p and assigned a value of 3.141 to it. But do you notice this const? This means that this is a constant and it cannot be changed. So if we run this program, it will print out 3.141. But if we try later on to assign a new value to this constant, we will have an error. It will show you build errors. Let me just run it and you'll see. Now you should see, you see, there were build errors. No, I know what I did wrong. So let me correct that. Here, where we tried to assign a new value to the constant, I'll just take that out, comment that out, and now when we run it, you'll see that it will print out 3.141. Let's look at that. It's out, sorry. 3.141. So this is a good example to show you that you cannot change the value of a constant. A constant is a constant. It's not a variable. You cannot change the value. So now I believe we are ready to start doing some exercises and see everything that we have learned today in practice. The first thing we're going to look at is the constant. You remember in your Solution Explorer, I told you you can have a lot of projects. So basically these are lots of projects. We have almost, let's see how many. We have about 17 projects here. But the first one we're going to look at is the constant. So we just run the program and it's already open here in my window. Remember that a constant is a memory area that keeps some value that cannot be changed. And you should also remember that it's different from a variable. In a variable, you can change the value anytime you want, but in a constant, you cannot change the value. So let's look at what this means here. Here on this line, we created a constant, a double-typed constant. We named it P and assigned a value of 3.141 to it. If we run this program, since we have written console write line P, what it should show us is P is equal to 3.141, or it will just read 3.141. But if we try to assign a new value to P, here I have tried to assign a new value, it didn't work. You can see it has underlined that in red, showing me that this is a mistake. So let's just take this out and run the program first and see. You can always start your program. You see here 3.141. That's the value of P, the assigned value. But let's try and see if we try in our code to assign a new value to P and see what will happen. Let's run the program again. Hey, you can see there were build errors. Of course, no, I know my mistake. And let's cancel that out. So you can see that you cannot assign a new value to P, or you'll have a mistake. Why? Because C is a constant. You cannot assign new values to a constant. The next on our agenda is casting. Casting or type conversion. This is basically converting a value of one type to another type. Here we have casting or type conversion is a conversion of a variable value from one type to another. There are two different kinds of casting, explicit and implicit. So two different kinds of conversions. The first one is implicit casting or implicit type conversion. This is a safe type of conversion. Why? Because you are putting a value of a smaller type to a value of a greater type. Imagine that you have a big container. Now, in that container, you can put something that is from a small container. So you have two containers. One is a big container and the other is a small container. Think of a bucket and a cup. I guess you can put the contents of a cup into a bucket very easily without losing any precision or without losing any amount of whatever you have inside. So that's why it's called an implicit conversion. Now, here you remember that a byte can hold a maximum value of 255, but an integer can hold a greater number. So if you are converting from a byte type to an integer type, it's the same thing as putting something that was previously in a smaller container into a bigger container. Of course, you will not lose anything. An integer has 4 bytes, 1, 2, 3, 4, whilst a byte has only 1 byte. So putting 1 byte into a container that can hold 4 bytes is very possible and safe. Here the value of our byte is 10 and the value of our integer is 0. So putting 10 into an integer is very easy. If I run this program, you will see that we'll have 10 as our first number, which is our example for now. Let's bring this down. You can see 10. So we have 10. It's not a big deal. You can put something from a smaller container into a bigger container. Everybody knows that. But what if we have a fraction? Let's look at how that happens. Implicit type conversion, safe, is a conversion of a value from an integer type to a real type. Integer type, remember, it means whole numbers. Real type means fractional numbers, like the decimal, float, and double. So in this example, we have 255, we have created a variable, an int-typed variable, and assigned a value of 255 to it, which is the maximum that a byte can hold. It's not a problem to put it into a float, because a float can either show or print whole numbers or fractional numbers. So of course you can, without losing any precision, assign the value of C to D. So here we have D, we have assigned a value of C to D. It's very easy. If I print this out, what you will see is 255, and it's very easy. Now, that is about implicit conversion or safe conversion. How about explicit conversion? Explicit conversion, on the other hand, is a kind of an unsafe conversion because you lose some precision. You risk the loss of some precision. Let's take a look at what I mean. Explicit type conversion is a conversion of a value of a greater type to a value of a smaller type. So it's the same thing as saying you want to put the contents of that your bucket into a cup. Yes, you will fill in the cup, but then you will lose other materials that you have inside. All the content that is left will be spilled out. It's like an overflow. So here we are trying to convert from an int type to a byte type. But then the problem comes here. A variable we created here, an int typed variable named E, and assigned a value of 256 to it, and then we have a byte type here. We want to convert this int type into a byte type. Well, the best way to do it is like to assign the value of the byte, the int E, into F, but we'll lose our precision. We'll lose our numbers. So here we are trying to assign the value of a byte into F. It's not gonna work. We're just going to see 0. But this is basically the way we do explicit conversion. You put your byte into open and close parentheses, and then you write E outside. E meaning our integer here, our integer value. This variable we created having an integer value of 256. So this will render 0, it will show you 0. But if you try to just like, assign the value directly, it will show you an error. Straight up, you will see an error and there's nothing that can happen. So don't try to convert like this. Conversion is something like this, but in this case it will not even work if we use F and E and assign the value of E to F. So another type of explicit conversion is when we try to convert from a real type to an integer type. You remember that a real type has fractions, whilst an integer type is a full number. So here we have created a variable, a float type variable named G, and assigned a value of 10.5 to it. This F means that this variable is of a float type. And then we want to convert it into an int type. So we also created an int typed variable named H and assigned a value of 0 to it. So you can try to somehow assign this value, and you have, like, for example, H, you assign in open and close parentheses an integer value, and then you write G here. This shows the computer that you want to convert integer into float. Float into integer, sorry. You want to convert G into integer. So this will not work. If you try it like this, it will never work. You'll always get some kind of error. Here you have cannot implicitly convert type float to int. An explicit conversion exists. Are you missing a casting? So what is this casting? This casting is basically this. You open and close your parentheses, you write the type that you want to convert to, and then you write what you want to convert somewhere here. So this is a kind of casting, explicit casting. The next one is a type of implicit casting with constants. Now, if you look at line 56, you'll see implicit casting of constant value from type int to type byte is possible. Now, I know type int is bigger than type byte, but there's a condition here. If the constant value doesn't exceed the maximum possible value of a variable, it is possible. This means that if the value of int doesn't exceed the maximum value of byte, then you can do it. Let's take a look at an example and see. Here we have created an int-typed variable, an int-typed constant variable named I, and assigned a value of 255 to it. And we want to convert this int-typed variable to a byte. But because 255 does not exceed the maximum value that a byte can hold, then we can convert easily. So here we created a byte-typed variable named j and assigned a value of 0 to it. Of course, you can put 255 into a byte without any problem, because 255 does not exceed the maximum capacity of a byte. So we can easily assign the value of I to j without any problem, and j will have a value of 255 now. So if we run this program, we'll see that j is equal to 255. You might just see 255 and you understand that. Next, we have explicit casting. Explicit casting of constant value from a float type to a byte type. This means that we are trying to convert from a decimal type to a full type, a byte type. Let's see this. If the constant value doesn't exceed the maximum possible value of a variable, it is possible. On line 71, we created a constant float type variable named k and assigned a value of 255. Again, 255 doesn't exceed the maximum capacity of a byte. Here we have created a variable, a byte-typed variable named L, and assign a value of 0 to it. So L can have the value of float if the float doesn't exceed the maximum and it does not contain any fractions. Here you can see how the construction of explicit casting, you have to open and close parentheses and put what you want to convert to, and then you put the value of what you want to be converted. So again here, if you run this program, you'll see 255. But what happens if the maximum possible value of a variable is exceeded? Let's take a look at this example. Here we have created a constant type variable of int type. We've named it m and assigned a value of 256 to it. But this time around, 256 exceeds what a byte can hold by 1. So although we have created a byte-typed variable named n and assigned a value of 0 to it, we cannot safely put this into this. We cannot put this 256 into a byte, because a byte can hold 255 as its maximum capacity. So what you will just see is an error if you try to convert this. Let's go down a little and see what we can do next. If the constant value exceeds the maximum possible value of a variable, it is impossible. So either a float, which is a decimal type, not decimal type, but a fractional type, either a float, which is a fractional type, when we are trying to convert it into a byte type, it will not work. You will just see error, because 256.5 is greater than what a byte can hold. Number one. Number 2, we have 0.5 here. It's a fractional number, so you cannot safely convert from a float to a byte if it exceeds the maximum capacity. On this slide, we have some arithmetic operators. We have the addition, subtraction, multiplication, division, and remainders. Let's take a look at them one by one and see how they work. The addition, or the plus sign, can be used to add two variables. Here we have created a byte-typed variable named summand1 and assigned a value of 1 to it. Simultaneously, we also created another variable of a byte type 2 and assigned a value of 2 to it. This second value we call summand2. So we have 1 and 2. This is called multiple declaration. Now, if we want to add these two, we have, for example, created another variable here, an int-typed variable named sum, and we assign a value of 0 to it. Now, if we create sum here and assign a value of summand1 plus summand2, what you should see is 1 plus 2, because the value of summand1 is 1 and the value of summand2 is 2. Basically, what it's going to do is it will add 1 and 2 and it will give you an answer of 3 here. So if you run this program, the first thing you will see is 3. Let's run it and see. You can see it here. So what it's doing is 1 plus 2 is equal to 3. That's very easy, and I guess I don't have to show you the rest of the examples, but let's just go on and see. The subtraction, on the other hand, subtracts something there. Here we created a byte-typed variable named minuend and assigned a value of 5 to it, and as a multiple declaration system that I showed you above, we also created another variable here named subtrahend and assigned a value of 3 to it. So if we create an int-typed variable here named difference and assign a value of 0 to it, we're trying to show our result in an int type. So difference, which is this variable, is equal to minuend minus subtrahend, meaning 5 minus 3. Of course, we should see 2 when we run this program. And this is your 2. So let's go on to multiplication. Creating a byte-typed variable named factor1 and assigning a value of 2 to it, at the same time creating also factor2 and assigning a value of 3 to it. What do you think will happen? 2 times 3, which is equal to 6. And we're trying to print the result in an integer typed variable we created and named product. So the product of 1 times 3 will be equal to 6. Again, let me just run it very fast and you'll see. 6. Here we go. 2 times 3 is equal to 6. So this is how arithmetic operators work. The next one we have is division. Here we have created a byte-typed variable named dividend and assigned a value of 5 to it, and also created divisor and assigned a value of 2 to it. So creating another integer typed variable named quotient, which was assigned a value of 0 to it, and remainder, which was assigned a value of 0 also to it. Quotient is equal to dividend divided by divisor. So 5 divided by 2. Of course, you will have 2, but then again, what you will need is you want to see the remainder. You want to see how many, what value will remain. Let's run it and see what will happen. Now, oops, 1 minute. Where is it? Okay. 5 divided by 2. You'll have it 2 times. And you'll have a remainder of 1. Simple. let me show you something. Here we have remainder after division. The percentage sign is used to show the remainder. So here we had 5 divided by 2, which is equal to 2, but we'll have a remainder. Here what we're asking the computer to do is to also print the remainder. Remainder is equal to, or the remainder is equal to dividend. This is the sign of it, and then divisor. So that's why we had 2 printed first. Again, I'll show you. 2 printed first because we'll get 2 2's in a 5 and then a remainder of 1, of course. The arithmetic of Visual Studio is very easy and you can always count on it. Our next example is about increment and decrement operators. So here on line 11, what we have done is we asked the console to write post increment. Post increment is basically saying that it should first display the value of a number and then increase it. This is how the operator works. Here we created a byte typed variable and named it number 1, assigned a value of 0 to 8. You can see it here on line 13. And then on line 14, we asked the console to take our value of number 1 and add 1 to it. So first of all, what will happen is the console will first display the value of number 1 and then increase it by 1. This plus plus is the increment sign, meaning that you want the computer to increase a value of 1 to whatever value you have assigned to your variable. So if I run this program, you should see 0 first displayed and then you will see 1. So 0 plus 1 is 1. Let's take a look at how it works and see. Again, you have seen here we asked it to write post increment. It has written post increment and the initial value is 0. Here you go. We have 0, 0, and then we increased it by 1, having a total of 1. Now, this is post increment, but then we have pre increment. In pre increment, what happens is it first increases the value of our variable and by 1 and then display it. Here we have created a byte typed variable. We have named it number 2 and assigned a value of 0 to 8. So when we ask the computer to do a pre-increment operation, what it will do is it will first increase the value and then display it. Here our variable is variable 2, number 2. Let's run the program and see. So you can see pre-increment 0 wasn't displayed as in post-increment. It automatically just added 1 to 0 and then displayed it without displaying the initial value of our variable. So the difference between post-increment and pre-increment is that in post-increment it will first display the initial value of your variable and then increase by 1. But in pre-increment, it will not display the value of your initial variable. It will just add 1 to it and then display it. The same thing happens with post-decrement and pre-decrement. Here we have created an S-typed variable named number 3 and assigned a value of 0 to 8. You remember that S-type is sign byte, which can have a positive or a negative value. So here we have asked the computer to do a post-decrement operation. First, it displays the value of 3, number 3, our variable, and then decreases it by 1. It will first show 0 and it will subtract 1 from 0, meaning we'll see 0 and then minus 1. Let's run it and see. Here again we have it. First, it showed 0 and then minus 1, the initial value, and then decrease the initial value by 1. Let's move on and see. We also have pre pre-decrement, meaning that the computer will first decrease the value of your variable by 1 and then display it. We also created an S-typed variable here named 4 and assigned a value of 0 to it. First, what the computer will do is it will decrease the value of our variable by 1 and then display it. So it will not show us 0. What it will just do is it will show us -1, which is 0 minus 1. Let's run it and see. So you see, in pre-decrement we just have -1. We don't have 0. It is not showing us the initial value of our variable. It is just subtracting 1 from the variable and then displaying -1 as our result. This is basically post and pre-decrement, and again post and pre-increment. Increment for addition and decrement for subtraction. In example 5, we are going to take a look at comparison and equality operators. We remember that we have the less than sign, less than or equal to, greater than or equal to. Well, these equal to signs, the two of them mean equal to. If you have just one, it's like an assignment sign, but here to differentiate it we use two equal signs. And this not equal to sign. This is the not equal to sign. Fine. So let's look at some examples and see what happens. Here we have created a byte typed variable named value1 and assigned a value of 0 to it. And as a multiple declaration, we also created a variable named value2 and assigned a value of 1 to it. So here what we are going to do is we are going to compare value1 and value2, which are 0 and 1, and see the relationship between them. If we want to use a true-false scenario, you remember that we're supposed to use the Boolean method or the Boolean type. So here bool represents a Boolean value, and here we created a variable, a bool typed variable named result, and assigned a value of false to it. Let's see when we move into greater than and less than and see if it will give us a result or no. Just remember the value of value 1 is 0 and value 2 is 1. So result is equal to value 1 is less than value 2. What do you think? Value 1, 0 is less than value 2, 1. Of course 0 is less than 1. So here we are going to have a true scenario. Let's run the program and see if we'll get true or not. True. So 0 is less than 1. In the next example we have greater than. Result, value 1 is greater than value 2. 0 is greater than 1. Of course you'll say, Rashid, it's false. So let's run it and see. And you're right, it's false. Next one is less than or equal to. Value 1 is less than or equal to value 2. 0 is either less than or equal to 1. Is it true? Yes, 0 is less than 1. So let's see if it's true. Again, you're right. It's true. Next, we have greater than or equal to. Value 1 is greater than or equal to value 2. 0 is greater than or equal to 1. That's false. I don't even need to run the program for you to know. Now, equal to sign. Again, we have a comparison here. Value 1, which is 0, is equal to value 2, which is 1. 0 is equal to 1. This is false. So here you are going to see false, and you have it just here. False. Remember, false, false. Next, we are going to look at not equal. Value 1 is not equal to value 2. 0 is not equal to 1. This is true. 1 is 1, 0 is 0. Everybody knows that. So it's true. So you can see how we can use greater than, less than, greater than or equal to, less than or equal to, and equal to, and also not equal to. This is how it is used in C#. Now let's take a look at how we can use the assignment sign in arithmetic operations. There is a rule here. All arithmetic operations executed with two values of byte, sbyte, short, ushort types return a value of int type. Meaning, any operation, arithmetic operation, you execute using two values of either byte, sbyte, short, ushort, it will return an integer value for you. So what do? You have a couple of options of how to do addition with the assignment operator. First, let's look at the sign for addition with assignment. You can see it here. We have a plus sign and an assignment sign. This is called the addition with assignment operator. So for values of a byte type, what you do is, let's first create a variable. On line 15 here, we have created a byte typed variable and assigned a value of 0 to 8. Now let's imagine we want to add a number to this 0. And that number is 5. There are ways that I'll show you that will not work, and there are ways that will work. The first method we are going to use is, we'll write our variable and assign variable 1 plus 5. So variable 1 is 0, 0 plus 5. This will not work. It will show you an error. Attempt of implicit conversion of type of result from int type to a byte type. It will not work. In short, it will show you an error. The second way you can try to do it is, write your variable, variable 1, and assign and try an explicit type conversion. You put byte in open and close parentheses and you write variable plus 5. This will also show you an error. You do not need to do this. What you need to do, however, is you write your variable and your assignment sign, and then you open and close parentheses, put your byte inside, open and close another parenthesis, and put variable plus 5. This is simple mathematics, and this is the only way it will work. It looks something like this, but the difference is here you don't have open and close parentheses where you have your variable 1 plus 5, whilst here you have it. So this will work, but it is a very long procedure. You can see it, yeah? The easiest way to do this is just write variable 1 plus with your assignment sign and put your 5. This is easy, it works every time, and you don't have to worry about writing a lot of things. Now, let's take a look at what happens if you try to add a value which exceeds the maximum limit of the type. Let me just zoom out a little. So here you are trying to assign with addition a value of 5,000 to your variable 1. Remember that we want to assign it to a byte type. So variable 1 addition with an assignment 5,000. Of course, a byte can only hold 255, so you can't add 5,000 because it exceeds the maximum limit of our byte type. And also for short type, if you exceed the limit, it doesn't work. So don't exceed the limit even if you are assigning with an addition. Let's look at another rule here. For int, uint, long, and ulong types, there is no type conversion. Results of arithmetic operation. So there is no type conversion, you just convert it and it will work. Let's see this. Operations with assignment. Addition assignment. Here we created an int-typed variable named variable2 and assigned a value of 0 to it, and we want to add with an assignment. So variable2, here you have your assignment sign, variable2 plus 5. It will work. You have it here, variable2 plus with assignment 5, and that's all. Subtraction with an assignment. Subtraction assignment. We also created an unsigned integer typed variable here named variable3 and assigned a value of 0 to it. Variable3 is equal to, or your assignment sign, variable3 minus 5. It's very easy to do it here. You can see variable3 subtraction with an assignment 5, and you'll have your answer. The same thing with multiplication. Created a long typed variable named variable4, assigned a value of 0 to it, and you have variable4 multiplied by 5, or variable4 multiplication with an assignment 5. Same thing with division. Same thing with remainder. So with division, you created a long typed variable named variable5 and assigned a value of 0 to it. So here 0 is equal to 0 plus divide by 5, or 0 division with an assignment 5. Remainder after division assignment. Remember, this percentage sign here or symbol is for remainder. So here again we created a long typed variable named variable6 and assigned a value of 0 to it. You have variable6 is equal to variable6 remainder of 5. So variable remainder with an assignment 5. Another rule you have to listen to now is for int, uint, long, and ulong types, there is no type conversion, results of arithmetic operations. The same rule you have there. So there is no conversion for this. For example, addition assignment. Here we created a float typed variable named variable7 and assigned a value of 0 to it. Variable7 is equal to variable7 plus 5. Variable7 addition with an assignment 5. So basically this is how you can add, multiply, divide, subtract with an assignment. It's very easy. What you just have to do is you just write your variable plus and with an assignment 5 or 10 or 3, whatever you want. Let's move on to local areas. What is a local area? A local area is basically where you have your open and closed curly braces. Here we have one local area and here we have another local area. So I named them local area 1. We have open and closed curly braces, and then local area 2 where we have our open and closed curly braces. So now we have some rules that we have to follow if we are to work with local areas. In a code, you can create a local area in two different local areas. You can store two variables with the same name. So here we have created an int-typed variable named a and assigned a value of 1 to it. And in local area 2, we also created an int-typed variable also called a, but assigned a value of 2 to it. So here we have 1 and here we have 2. The same name, it's not a problem. Why? Because we have them in two different local areas. Although they are of the same type, the same name, but they are in different local areas. So if I run this program, what we should see is 1 and 2 will not have an error. Here we have 1, 1, 2, 2. No problems whatsoever. Let's look at another rule. If you have a local area, it is forbidden to store variables with the same name inside the local areas. So don't try to put the same name of a variable in the same local area. If you have, for example, in local area 2 and you have a variable already named A, then don't try to do that, because you have created an int-typed variable named A and assigned a value of 5, for example, to it. It will not work. It will show you an error, and what it will say is a variable with the same name already exists in the local area. So in the same local area, you should have different variable names. But if you have different local areas, then try and name them with the same name, and it's possible. How about naming variables using keywords? In some cases it's allowable, in other cases it's not permitted. Let's take a look at some of them. Here, for example, on line 11, we have created an int-typed variable and we named it bool and assigned a value of 5 to it. This is not allowed. Why? Because bool is a keyword and you cannot just name it bool and that's all. But if you want to name it bool, what you need to do is to add this @sign. So we created an integer typed variable named @bool, just something like this, and assigned a value of 7 to it. This is allowed. So the character, the @character, is not part of the identifier. So @my variable is the same thing as my variable. We have the same thing here. If you put bool is equal to 5, or you assign a value of 5 to bool, is the same thing as saying @bool. There is no difference just because you put the @sign. So let's look at another example here. We created a string typed variable named my variable and assigned this to it, hello. So console write line my variable. It will write hello for you. Let's take a look at that and see. You can see here that we have 7, which we assign here, and we have hello, which we assign here. This proves that @ is not part of the identifier. It's not part of the variable name. It's just there to follow the rules. Let's take a look at what you would do if you want the computer to check if you have an error in your arithmetic multiplication or division or subtraction, or if you just want to uncheck and then tell the computer that don't worry, let's just go on, ignore the problem, ignore the error. Here we use the words checked and unchecked. So if you want it to check for an overflow, this is where you write checked. But what is an overflow? An overflow just means that the variable value you have assigned is more than the value that the type can handle. For example, if you assign a value of, let's say, 5,000 to a byte, it's of course greater than what a byte can handle, so there will be an overflow. Just imagine that you have a 15-liter bucket and you're trying to put 20 liters of water into your 15-liter bucket. Of course you will have an error. Not an error, but a spill. Well, in computer programming, it is called an overflow. That is basically what an overflow is. So if you want it to be checked, if you tell the bucket to check it, the bucket will check and just tell you that, guys, I can't handle 20 liters, I can only handle 15 liters. So it will just tell you stop the operation. But if you write unchecked, what the bucket will do is it will just accept the 15 liters it can handle and then spill out the rest. So you see the difference between checked and unchecked. Let's look at this example, and I believe that you will understand more if I explain it in this way. Now, remember I told you that the computer understands the binary system. So let me just write a B here so that you will understand that this is in the binary format. So when you write, for example, an S-typed variable, if you create an S-typed variable, name it A and assign a value of 127 to it, it's fine. But remember, an S byte can hold a negative and a positive value. So here, the value of 127 in a binary format is something like this. In the S byte type, the first digit here, or the first position here, determines the value, whether it's a positive or a negative value. If you see a 0 at the beginning of an s-byte typed variable, it means it's positive. If you see a 1 in the beginning, you understand that this is a negative value. So, we have created an s-typed variable named a and assigned a value of 127 to it. Now, we write checked. We want the computer to check if we have an error or if we have an overflow. So, remember this. We're adding 1. It's the increment sign. So, our variable a, that's our variable, plus, meaning a plus 1. That's what you're telling the computer to do, to add 1 to this. But then again, you have to understand how the computer works. 127 plus 1, the computer will take it as minus 128. Why? Because it's an s-byte. If it were just a byte, then you would have 128 without any problems. But because it's an s-byte and the range is from 0 to 127 for positive and then 128 upwards for negative. So here you have 0, 1, 1, 1, 1, 1, 1. This is 127 in the positive sense. If you add 1 to this, this 1 will change. It will change to 1, and then you will have 0, 0, 0, 0, 0, 0, just like here. So this first digit here, being it 1, will tell the computer that it's negative. So it will read minus 128, which of course will show you an error, compiling error. You have made a mistake. Please check if you need some corrections or whatever. So this is how it works. Let's look at unchecked now and see the difference. Here we have created the same scenario. We've created an s-byte type variable called a and assigned a value of 127 to it again. Again, here you have something like 0, 1, 1, 1, 0, 1, 1, 1, and 1, 1, 1, 1. Then here, of course, you have 1, which is the first letter for a negative, and then you have 0, 0, 0, 0, 0, 0, 0. So what the computer will do is, when you write unchecked, it will just accept what it wants and leave the rest. So here you will not see an error. If you add s-byte named a and assign a value of 127 to it, and you write unchecked, you will get a value of 128 in the negative value. Now let's run this program and see if it will write minus 128 or if it will show us an error. Let's just run it and see. Bring it back here. You can see here minus 128, variable unchecked. So you can see it here. It will just omit it. It will just, like, ignore the problem, ignore the mistake. But let's go back to our checked value and run it and see. Here we go. Overflow exception was unhandled. An unhandled exception of type system overflow exception occurred in check. Additional information, arithmetic operation resulted in an overflow. So you have an overflow if you write checked, and it will not display anything because it's checked and you've made a mistake. But in the unchecked, there will be no overflow. It will work. Again, as we go on, I'll explain more and you'll understand more of this as we go on. So don't worry, you'll understand it in the long run. In the previous two slides, we looked at checked and unchecked. Using SignByte, we noticed that we couldn't increase the positive number 127 by 1. It will give us an error, or it will give us minus 128 in the unchecked version. So let's look at how we can combine this checked and unchecked and put them in the same code. Here is an example. We created an S-typed variable named A and assigned a value of 126 to it. We also created another S-byte typed variable, named it B, and assigned a value of 127 to it. Now here we have checked, and we open and close with these curly braces. In this block we have A++, meaning, if you remember, A++ means to add 1 to whatever value you have. So A here, 126 plus 1 is 127. In this case, we are correct. We will not have an error. We have not passed the limitation of 127. Then within this checked block, we opened another block. You can see here, open and close curly braces, and then we uncheck B, which means we don't want the computer to check B. We don't want it to check for errors or overflow. We just want it to write it as it is. Just we're interested in the result. Then after closing block B for unchecked, we also add another one to our 127 that we have here. Remember, A was 126, we add 127, and we're adding another one here, 128. No, it's not 128. We'll get an error here because it's in the checked block. We're already out of the unchecked block. Now we're in the checked block, so it will check and it will tell us, no guys, you can't add 1 to 127 in the S byte because you will change the value. Alright, now let's try and step this program and I will show you how things will work here. Remember to use F11 to step your programs. F11. Now here you can see our 126 for A, 127 for B. We move down and here we have the value of A is still 126, but when we go out you'll see that the value has changed to 127, meaning we have added 1 to this A. Now we have 127. So we go to the unchecked block. Now we don't want the computer to show us any errors, and you can see here the value of B is still 127 as it was. So we move down, we add 1, still 127. Immediately we step out of that, you will see B has changed to minus 128. But the computer didn't warn us. Although we have A here at 127, we have not passed the limit of S byte in the positive section. So no error yet. Now if we step again, here you can see we still have 127, but once we want to step out of this to increase 1 to our 127, we'll have an error. Let me show you what I mean. Oh, you see it here. Overflow exception was unhandled. An unhandled exception for type system.overflow exception occurred in checked_unchecked.exe. That's the name of our project. Additional information, arithmetic operation resulted in an overflow, meaning we have an overflow right here. You can see a line showing us right where we have an overflow. But what happens if we take this out of the equation? Let's try and take this out of the equation. Let's stop running the program. You see, stop debugging, and let's run it again and see what will happen. It didn't show us any errors. You see? So basically that is how you can combine checked and unchecked in the same program. Even you can put checked in the same code and have unchecked in the same code too. The computer will just ignore the unchecked and check what you asked it to check. Another thing I want us to look at is concatenation. This is the operation of joining two character strings end to end, meaning you have two strings and you want to put them together to have one screen that has another meaning. Let's take a look at this example. Here we have variant 1 and variant 2. which means there are two ways that I will show you today of how to concatenate. The first variant is when you create a variable, a string type variable named word1, and you assign a value of, let's say, hello to it. Don't forget to put these quotation marks, they are very important. So the value of our first string is hello. And then we create another string, name it word2, and assign world to it. Now, this is what happens. When you have string face is equal to word1 plus word2, what will happen is this is not a plus. This is like join word1 and word2. So this sign is called concatenation sign. Here what we are going to have is the computer will put word1 first and then word2 second, meaning you have hello world. It's very easy to do this. Let's run it first before we go to the second variant, and I'll show you how it will turn up. This is it, you see, hello world. This is for the first variant. Now, the second variant is even easier than the first variant. The second variant is just you write console.writeLine, you open and close your parenthesis, and within that have your double quotation, and you write hello, you close your double quotation, put the concatenation sign, and you open another and close double quotation, and you write world there, and what you will have is it will join these two words together. And of course, when we run it, you will also have the same result, hello world and hello world. So here you have a longer version of doing it, and here you have a shorter version of doing it. You choose any one that is easier for you and more comfortable, and then you can do that. Practice it and we'll see how it comes out. Let's go ahead and take a look at something very easy, but yet very important. String format. What is this? Just don't worry about this string format, not string format. Just look at what I will do here and you will understand everything and see that it's very useful, but yet it saves you a lot of time and it's very easy to use. So here again in this block that we have created, what we are going to do is we'll create an int-typed variable named a and assign a value of 1 to it. I guess you already know that now, you can read it. And then we write console.writeLine, open and close parenthesis, and we write this is number, and in our curly braces we write 0. Then look at this. After this comma we put a and we close our parenthesis. What are we asking the computer to do? We're asking the computer to take the value of a and put it in here. So the value of a is 1. What we're expecting to see when we run this program is this is number 1, not this is a, not this is 0, and you're not going to see this curly braces. So let's try and run the program and see what will happen. F5 to run your program, always remember. It's out, sorry. Here we go. This is number 1. This is number 1. So you see it's very easy. It's an easy operation and everybody can do it. So let's go on and see if we have 2, 3, 4. In fact, you can have a lot of variables and just put them in as you go on. So here we've created another integer typed variable named v and assigned a value of 2 to it, and created another one named c, assigned a value of 3 to it. Then we ask the console, write this line out. These are numbers 0 and 1. We want the computer to take the value of 2, put it in here where we have the 0, take the value of 3 and put it in here where we have 1. Remember, I told you it's all about the indexing. So this is 0, this is 1, and if we had another one here, it would be 2, 3, 4, 5, 6, and so on and so forth. So if we write the numbers 1, 0 here, it's going to reverse it. But anyway, let's just try this. So let's try. B gets into here, C gets put in here. The value of B is 2. The value of C is 3. So we should expect these are numbers 2 and 3. Okay, let's run the program. And here we go. These are numbers 2 and 3. It has taken the value of 2, put it in here, taken the value of 3, put it in here. You see? Very easy. How about if we want to reverse it? Reversing it means that we're just not going to follow the index sequence. We're just going to play with the numbers. So again here, repeated for the same values. We have these are reversed. I put this reverse so that you will understand that this is a reversed version. We put 1 and 0. Remember here we have 0 and 1. In this case we have 1 and 0. So what the computer will do is, to the computer this is 0 because the computer always starts counting from 0. So this is 0, 1, 2, 3, 4, but here we just have 0 and 1. So where will it put B? It will put it right in here. So B will be here and C, which is number 1 here, will go in here. So these are reversed. 1 is what? 1 is C. So these are numbers 3 and 0 is what? 0 is B, which is 2. So we're expecting to see 3 and 2. Yes? Let's run it and see. Here we go. These are reversed 3 and 2. You can see how easy this is and how you can just play with these numbers and their positions and create whatever you want. Let's move on to the next slide and look at flag formatting. So here we go. Flag formatting is used when you want an output with a sign, or maybe you want to change the output of something. So here we have console write line. C format is this C representing currency here for us. So if you write console write line and you write 0 C in open and close braces, after the comma you write 99.9, what you will see is you will see this 99.9, maybe you'll see 99.90, it will round it up, and then you'll have it in your currency. If your currency is set to dollars, you'll see $99.90. If it's in pounds, 99.0 pounds. So let's run this program, and I guess you'll understand what I mean when I'm showing you the real thing. Here we go. Here, my currency is set to dollars. So what you will see here is $99.90. It's rounding this up, so you understand what I mean. Now the next thing is if you want it to be in a fixed precision. By fixed precision, what I mean is just you'll just have a number without any sign. It will also round it up. So here we have 99.935, which is very close to 100. What you'll just see is 100. So for fixed precision, where we use this double pound signs, what you will just see is 100. It's a fixed precision, no dollars, no pounds, no percentage, nothing here, fixed. The next thing is when you want it to be in a standard numeric format. By standard numeric format, you understand that it's just, you know, how the numbers are put and the commas and, you know, punctuation there and here. So if you have 999999 and you just want it to be in the standard numeric format, let's say you don't know what it is, so you write N, which represents standard numeric format, and what you will have is 99,999.00, and it's that. The computer has done that for you. You don't need to do anything. Now if you want it in a hexadecimal format, we have, for example, here a decimal number which is 255. So imagine you want this number in a hexadecimal format. Remember, 0x is for hexadecimal. So you write OX and your output is going to be in a hexadecimal format. You can see it here, it's FF. FF is 255 in the decimal format, but in the hexadecimal we have FF. You remember from our first video where you saw there. Now let's move on to the next one. If you have FF, which is in the hexadecimal format, and you want the output to be in a decimal format, what you need to write is D for decimal, 0D, and you have it here. So your output is going to be 255. The next one is when you want an output to be in an exponential notation. What you'll do is you write E, standing, which represents exponential. So 9999, you can see the value here, 9.9999000 exponential and things like that. So if you want it in a general format and you don't need any, let's say you don't need it to round the number up for you, just want it to print what you have written, you just write G. So 99.9 in a general format will be 99.9. Nothing happens. The next one is if you want it in a percentage. 99.9 and you write P, which stands for percentage, you will have it like this, 9.9900%. So this, you're getting your output in a percent. Now, this is basically how this works. Next, let's take a look at the size of operator. This operator allows you to get the size of a value in bytes for the specified type. Size of operator can be applied only to these types. It can be applied to byte, sbyte, short, ushort, int, uint, long, ulong, float, double, decimal, char, and bool. So let's take a look at these examples one by one. Here we've created an integer typed variable named double size and assigned a value of size of double to it. So what we want is we want the computer to put the size of double here. So we write console write line. This is what we want to be printed out. Size of double type, and remember this open and close braces, we want to put what is outside this quotation marks, we want to put it inside here. So what do we expect here? We expect to see the size of a double size in bytes. Let's try it and see. Let's run the program and it will be easier for you to understand. Let me just bring this inside and resize it. So here we go. Size of double is 8 bytes. Next we have console write line size of int type 4 bytes. So size of int types 4 bytes. Size of bool 1 byte. Next we have size of long, and it's written here size of long 8 bytes. Size of short 2 bytes. So you can see we're taking these sizes and we're converting them into bytes using size of. So we want the size to be in bytes. It's very easy and very helpful to know this. So you can see how we can use size of and how to get the values of another type in byte types. Let's move on to the next slide and see something about variables. Well, on this slide what we have is var. Var is a very useful type. Why is it useful? It is useful because the computer helps you to determine the appropriate type of your variable. Here, for example, I'm writing 7. I can write byte, for example. Here I can create a byte typed variable named my byte or whatever and assign a value of 7 to it. But here I just use var. Var, my variable, my var, and assign a value of 7 to it. So just by creating this var typed variable and naming it my var and assigning a value of 7 to it, what happens is the computer will choose which type is appropriate and put it for me here. It can also be used for characters, strings, yeah? For example, I can write var, my var here, and assign hello, for example, to it. The computer will automatically determine which type it wants, which type is appropriate for it. So it makes our work easier. So when I write console write line, I will not get an error here. It's just going to print 7 for me. Let's run it and see. So you see, the computer has automatically chosen which variable type to use. Alright, now remember you can use it also for words, for let's say characters, for strings, and just write var. So the var type is a kind of flexible type, but there are some restrictions. What are these restrictions? Implicitly typed local variables do not allow multiple declarations. So you cannot have var a and assign a value of 1 to it, B, 2, C, 3, you'll get an error. This is multiple declaration, and the var type does not allow multiple declarations. Implicitly typed local variables have to be initialized. So you can't just write var a, you'll get an error. You have to initialize it. And remember, by initializing a variable, what we mean is assigning a value to it. Here, you see we don't have the assignment sign. So this value has not been initialized. It hasn't been given a value. So this variable is not a variable now. It's just a variable that has not been initiated. Constants can't be implicitly typed local. What it means is we can't have const variable my var is equal to. You'll also get an error here. So you can't use constants. You can't use it if you haven't initialized it, and you can't do multiple declarations. But it all works in other cases. So it's very easy. It helps you do your job faster, and it helps you choose which type to use. Our last example today is about comparing values of different types. You remember how to compare values, having the greater sign or less than sign, or equal to or not equal to, or greater than or equal and equal to. So something like that. Now let's look at this. Here we have some rules I want you to see. Remember, bool, it represents the Boolean value, and it has a true or false result. So bool result int, we create a variable, an int typed variable here named a, and assign a value of 1 to it. We also create a float typed variable named b and assign a value of 2.0 to it, having this f to represent float. So we try and run this. Result is equal to a is less than b. Let's see. A is 1, b is 2. So of course a is less than b, and this is a true scenario, and it's okay. So here we have comparing values of int type and double type is allowed. Of course you can compare 1 and 2 because they are all numbers. But let's take a look at string type. Now remember, we have string types that have some words inside. For example, hello, hello world, and so remember when we did concatenation, yes? So here we have created a string typed variable named c and assigned hello to it. Now of course we cannot compare hello and, let's say for example, 1 or 2. So result here, if we try to run this program, we'll receive an error. C, which is hello, is less than a, which is 1. How can c be less than a? They are of different types. These are words, string words, for example hello, and of course we have the int type is 1. So comparing values of int and string types is not allowed. Next we have flags. Here we created a bool typed variable named flag and assigned a value of true to it. Now let's take a look at this. We want the computer to compare 1 and flag. Flag is true. So how can you compare 1 and flag? It's not possible. So comparing values of int and bool types is also not allowed. And that's it for this lesson. I hope you've learned something useful today, and I would like to thank you for your time and attention. Till we meet again on ITVDN.